So this is a problem from your textbook. It's from section N. It's problem number 1. We're going to do 1 and 2 together, and I gave 3 and 4 for you to do on your own. But I thought it would help for you to see these problems so it didn't overwhelm you when you were doing them on your own. So we have a ball that's thrown upwards, height in meters, above the ground in seconds, and here's the function that models that. So we need to find the height of the ball when time is 0 and when time is 2. That's not tough. So for letter A, we're going to look, oops, I screwed up right there. Let me just erase it so I don't confuse somebody. So for letter A, I'm going to take and substitute in 0. So I've got negative 4.9 times 0 squared plus 19.6 times 0 plus 1.4. And that whole thing equals 1.4. Okay. All right. So then, when I'm finding h of 2, I'm going to substitute that in as negative 4.9 times 2 squared plus 19.6 times 2 plus 1.4. And I think I messed something up in my example, so I'm going to recalculate that real quick. No, I'm getting 21. Okay, great. So I needed those anyway to do my part B. My part B says let's find the average rate of change. Average rate of change is going to be my slope between those 2 points, so between 0 and 2. Now, because we're talking about velocity being specific with its sign, we want to make sure we do it in the order that it's given. So this is going to be your first point, and this is going to be your second point. So, well, actually, it wouldn't matter, but whatever. So I'm going to put my second point in. Those are my x values, so I'm going to have 2 minus 0 on the bottom. And the y-coordinate that goes with the 2 is 21, and the y-coordinate that goes with the 0 is 1.4. So I'm going to do 21 minus 1.4, and that gets me 19.6, which I'm going to then divide by 2, which gets me 9.8. So that's telling me that between 0 and 2 seconds, my velocity, my average velocity between those 2 seconds is 9.8. So average velocity is basically saying that if we found the instantaneous velocity of every single point in between 0 and 2 and averaged them together, we would get 9.8. But we'd much rather actually find the instantaneous rate of change. And the instantaneous rate of change, remember, involves finding the derivative. So let's go ahead and find the derivative of our function, and that gets me negative 9.8 t squared plus, oops, the derivative. I'm doing the derivative, so the squared went away, plus 19.6. And it very specifically wants you to find it at 1 second, 2 seconds, and at 3 seconds, and compare what's going on with them. So if I substitute in 1 second, I'm getting, so that's 1 times that, plus the 19.6, I'm getting 9.8. If I substitute in 2 seconds, 2 times that is negative 19.6, plus 19.6 is giving me 0. And if I substitute in 3, so at 3 seconds, that multiplied by 3 plus the 19.6 gives me a negative 9.8. So you can see velocity, like I said, gives you the direction. So this means that it's traveling upwards at a speed of 9.8. This means that it's not going anywhere. And this means it's traveling downwards at a speed of 9.8. So these two things match speed-wise, but because velocity gives us the direction, we can see that they're actually two different values.